But then I was following the usual concerns of most people that we talk to, and obviously the usual concern is the cost, right? Time is what we put in, and the quality is the problem that's going to bring us all down in the end. Thank you very much. Retrofitting, cost, time, quality. Let me just run through those things. People quite often think that, or say the problem with retrofitting is government's not putting enough money in it, or there's not enough incentive, and so on. And the fact is that you could look at it from another angle. Things are just too darn expensive. I mean, I've done Retrofit for the Future, and that was probably the top of insanity when it comes to cost. But at the end of the day, we're still not far. We haven't moved on, right? We're still using the same products that were designed for totally different buildings. We're trying to apply sort of new built approach into playing with existing homes, and it's just not cost effective. Time. Well, yeah, retrofit is a nightmare. I mean, we either move people out and it takes weeks, right? And for those insane folk that try to do it with tenants in situ, it's just a joke, right? And I've done in situ retrofitting, and it's horrendous, right? And you end up with claims, you end up with nobody likes anyone at the end of it, right? And it just doesn't work. The time also has the bit that should cover disruption, right? So we either have to move people out, or we have to turn their lives into hell for a considerable amount of time in order to do something to the building that we don't know if it's going to work or not. It just doesn't sound right. It doesn't seem to make sense. Quality is what, well, you've heard it, right? I don't think I need to add much to it. But we're nowhere near where we should be. So that's in theory, that's retrofitting in theory. Keyboard. Cheaper, faster, better. And that sort of gets people attention. It's not like better but 10 times more. We're not asking people to commit to something insane. This is something that is cheaper, is much faster and much less intrusive, and it's a lot better than the comparison. What are we talking about? We're talking about how to treat homes. Yeah. So yes, there is sort of 8.8 million, 9 million, whatever it is that people think about. Pre-1919 properties. When you start looking at what's been split up, what's multi-apartments and so on, we're talking about 6.5 million homes in the UK that have suspended timber floors, and this is what we're looking at, right? And they generally sort of between E and G when it comes to energy performance. So, pretty cool. Now, when you look at the actual numbers, what we've done to those properties, a lot of lofts have been done. Some people might claim that 99% is an inaccurate number, but that comes from DEC. We've done 70% of cavity walls, which do not apply to those properties, so they're completely left untouched. And we've done 3% solid walls and floors. Some might say that's very good. That's only 3% properties that need to be demolished and rebuilt in 5 years' time. But at the same time, we're talking about a whole array of properties that A, lose most heat, B, are the most uncomfortable to the inhabitants, and C, we're doing nothing about it. Now, what's the alternative? I mean, you've seen lots of lovely images, but things we do to those buildings are generally too expensive, too disruptive, and the quality is just not there. And on quality, there's a number of things, but generally installation fails, but also doesn't perform as well as anticipated. And with insulating properties where people are in fuel poverty, well, we're delivering zero energy savings. These people might be able to heat the properties up by an additional 2 degrees, right? But they're not going to spend any less money or use any less energy. They just, as opposed to living in 14 degrees C, they're now in 17, right? They're still not warm. So the whole carbon saving and everything else is an odd concept at the moment, but that's what people judge those by. Funnily enough, when you actually look at a property in detail, solid wall insulation, or solid walls don't lose as much heat as we generally assume, but a hell of a lot of heat is lost to the floor. And how does it work? Very simply, we not only conduct the heat out, there's lots of infiltration, there's lots of fresh air coming in from outside into the property and carries a lot of cold air with it. Now, fresh air is great, brilliant for ventilation, but if it's winter and you're getting 0.5 to 1 air changes per hour, which is completely uncontrolled, the house isn't heatable. And that is the main challenge, is actually lots of cold air coming into the building, freezing the tenants and the inhabitants. And the other thing is, that's lots of cold air at low level. Right? This is where you're most sensitive to it. So you're heating those properties up to 28 or something like that in order to be comfortable, and that's around your head, right? And you're still sort of 16 down the bottom. You're not comfortable. Whatever, you know, however much the radiators kick out the heat, it doesn't work. Right? So it's a fail, needs to be fixed. Now, okay, well, let's fix it. Let's move the tenants out. Let's rip up the carpets, get all the furniture in storage, probably chuck some of it. Let's remove the skirtings. Let's remove the floorboards, and then we expose timber joists that make cutting insulation to fit impossible. It's not only they run in all directions, they twist and warp, right? And if you look at research on insulation, if you've got 1 to 2 millimeter gap, right, in between the insulation boards, your performance is reduced by 10% plus, right? But 1 to 2 mil, this is your probably best fitting part, right? You can put fingers through the insulation when you put it there, because it's just impossible to cut it to size. It's just, it doesn't work, right? So you put insulation in badly, you need to suspend it somehow. If you're sort of smart enough, you probably put some sort of DPC or DPM on top of that to make sure that moisture from the house is not penetrating into the timber, and you build the house back again, right? So you put the floorboards back in, you put the skirtings back in, right? You put the carpets in, and you buy new carpets because the old carpets have been ripped up, right? You move all the furniture in, you move the tenants back in, and then you start the claim process about the furniture's been damaged and all that sort of stuff, right? And for housing associations, keeping tenants out for 2 weeks, that's £5 grand. Yeah, that's before you even touch the house. I mean, this is how insane the current approach is, right? But we're doing it because, or we're just not doing it. We've got cold bridging, we've got solid wall insulated properties with lots of cold air coming from the floor. Right? So you get insulated walls that do nothing to your comfort and nothing to your energy savings. So that's just how to reduce it, right? Cost, performance, this doesn't work. Hence the device. So yeah, people call them robots, and people get excited about robots, and it's like, well, it's a robot, it's like a human, you know, and it just crawls under the floor and sprays. The reason the device is that size and shape because it can fit under the floor, right? Because we need something that fits under the floor that can get from one end of the property to another end of the property without human intervention, right? These things are not light. They weigh about 30 kilograms. They've got massive motors that are sort of concealed in wheels. They've got a big spray gun, and they can pull me on the floor. The reason why they're so powerful is because they pull quite a thick umbilical that supplies the spray from the outside of the property, so we can spray the floor from underneath. The process. At the moment, we sort of to that level of insertion. Ideally, in the future, we'd like to go in through something like a 7-inch core hole, where we could just drill through the property without entering the property or even knocking at the door. Hopefully, get to the right house. And we could just insert that. The device does the job, and then the device leaves the property. We're talking about something like 1 to 2 days. At the moment, of course, it takes a bit longer. It takes probably 5 days on site because we're still learning, right? But the idea is you put that in, the device surveys. So we've got laser rangefinders. We get very specific height data from the property, joist positioning, and then you start spraying. So that's the floor after it's been done. You can see the ground is a bit uneven, but still reasonably good. Only a few sort of def trap electrical cables and so on. We get to see a lot more of that. That's that. Job done, right? After that, you do another survey. So you can actually validate the thickness and the coverage of the insulation. You can come up with a printout saying, this is what we've done. Yeah, right? Whoever does the job, we get the data. Yeah? So we know exactly how much insulation is there, where it is, and we'll be able to work at the performance of that floor. Now, the details, right? It costs 1/3 of what it would to rip the house apart, right? And you don't even have to, unless you've got some seriously problematic issues with sleeper walls and so on, which you might get, yeah? In half the cases, we don't even have to enter the house, yeah? The job gets done from underneath, 1/3 of the money, right? 1 to 2 days. Yeah? There's no longer decanting tenants for 2 or 3 weeks, no longer having sites that are insanely unsafe. I mean, I've ripped the floor up. I know what you get, right? You get 4-inch nails, yeah, sticking around waiting for you to put your foot on, yeah, on one side of the floorboards, and on the other side you get the carpet tacks, yeah, and the grippers. It's not pleasant when you step on that and it goes right through to the bone, right? It's not good. And if you're lucky enough not to do that, if you misstep, right, you've got half a metre drop, right? So you need to watch how you land. And I mean, you know, builders on site do things in a rush and a hurry. It's an unsafe site, right? And Jesus, it's 21st century, right? And we're doing things like Egyptians. It's to me that's lunacy, right? 2 to 3 times energy savings. Why? Yeah. Why don't we claim better energy savings? Yeah, polyurethane is polyurethane. We actually did some tests, and they were very exciting. We cut some unnamed polyurethane insulation by a national supplier, and we cut it pretty well because we built this test cell where the timbers were parallel, and they were very straight and new. So we had a good chance of getting it right. So we cut the insulation, we whacked it in, and then we put DPM over that, and then we ran tests for a few weeks. And we had thermocouples, we had heat flux sensors, we had velocity sensors because we were sort of blowing air underneath it and so on. It was great fun. And it was twice as good as putting carpet on. That's it, that's what you get. Because you've got gap, next to the gap, next to the gap, next to the gap, next to the gap. And you might as well be putting bars of soap in it if you've got this many gaps, right? Because the air gets through. Yeah, the floor is still exposed. You've got thermal bridging because each timber has a thermal bridge, and so on. It does not achieve, yeah, what a hot box with a sheet of insulation will tell you. Purely because when you're putting it in, thermal bridging is not that sort of 15 to 20% that normally calculators allow. So it is much better because this, I've got a sample, forgot that. Because this is how it works, right? So we've got a floor, some timbers, a section through. Yes, when you look at it from the bottom, it's sort of casted ice cream or something. But when you look at that, right, the floor is totally encased. Right? There is no thermal bridging here. Right? There's no infiltration here. Right? That's tight as you can get it. And when you spray, you probably get a gap somewhere. Right? But at the end of the day, when you look at the total volume, you don't actually get this nice surface between the insulation and the floorboards, where the air can naturally move around and take all the heat away. This is tight, yeah, that's a sealed floor with greatly improved air tightness and all the timber, yeah? I mean, when you think about the dew point, right, where's that? God, it's there. This is where condensation happens, right? Way away from the timber, and timber is all on the exposed, warm side of things, right? So in theory, it should work. Moving on. Zero disruption impact, right? Okay, that's the ideal. In some cases, we might say, okay, we're going to have to lift up that corner because we can't get to that section, right? But in theory, we could do all that and achieve all the energy savings without actually waking the tenant up. Which is good because that comes half a day. We're really gained. U-value. These are real site tests. So we've done lab tests, we've done site tests, and we've built our own kits so we can actually play with different levels of air tightness and so on because you can't really tweak the air tightness in the house, right? Starting U-value, yeah, 2 watts per meter square Kelvin, and that's including not just the timber but also the voids and the access to the outside, the airflow and so on. We're down to 0.3, right? Air permeability, tested on site with BizRia. We're from 16 down to 9. Air changes per hour, as you can see, we're from sort of at atmospheric pressure. Yeah, we're from almost 1 air change per hour, meaning every hour you lose all the heat from the house, right? To 0.37, and that includes not just the floor, that includes the whole dwelling, right? So single glazed sash windows, all of that is included in this calculation. And then temperature difference, and that's a big thing. And this is one of those things that, it's like Colin was talking about the U-value of the floor, it's different heights, different facades and so on. The stratification of temperatures in the dwelling makes a massive impact on how you actually set your thermostat. Right? So if your starting point is 4 degrees C, that means your head is 4 degrees warmer than your feet. Whatever temperature you're at, you will feel cold, you'll feel cold feet, right? You'll be uncomfortable because you are used to the temperature that your head is at, And you'll keep upping the temperature, assuming you can afford to heat the place, right? Which is insane, because that loses a hell of a lot of heat, right? You start running a thermostat at 24, 26 or whatever, and it's only due to the stratification, right? When you reduce that stratification to 2, right? You start, and that's 2 up 2 meters effectively, right? It's below detectable level, so all of a sudden you feel that all of the air in the room is of the same temperature. You can run a thermostat at 22, 20, 18, whatever's comfortable, right? You no longer have cold feet. And think about it. Just that fact that you can run your thermostat at 20 as opposed to 26, right, in order not to feel discomfort, that's 6 degrees. That's an insane saving. And nobody's actually calculating that in because there isn't a model, right, to take that data. Yeah? But that could actually be the biggest part of the energy saving. The fact that your feet are no longer cold, you're no longer set to temperatures that are insanely high. So I think that's a big difference. Real people! Yes? This is an actress. So we have talked to the tenants, and Miss Chapman was actually caught stuffing newspaper in between her floorboards on the initial inspection, because we did that in November. And she gave us a whole story about how uncomfortable the house was, and she just couldn't live with this any longer. And it was very interesting to see her sort of tearing up newspaper pages and just rolling it over and trying to shove it in between the floorboards. And obviously you walk one, back and forth, and that drops. So it kind of it's a game the whole family can play. After the job's been done, she was over the moon, and she came up with all sorts of other fantastic things that it did, and some of the things we didn't anticipate, like it's a lot quieter now, and and so on. The fact is, the flat is comfortable. The tenant is happy. There is no claim. Housing associations like that. So in her house we did actually have to cut one floorboard in one place, and so we fixed it up, and she was still okay with it. So we've got non-intrusive retrofit that makes tenants happy at a third of the cost, twice the performance. I mean, come on, guys, yeah? Where's the catch? So I keep talking about the numbers. Let's look at the numbers. We've got external wall insulation, and that's, could be 8, could be 10, could be 15, depends what you specify, right? Costs a lot. Internal wall, again, almost 10,000. High intervention, you probably ruined the house. That sort of, 8,000 doesn't include the fact that the plasterers have ruined the carpet and the cats escaped, right? So all of these things that come with intervention and disruption are not actually included in the cost. When you start adding those up, like moving tenants out or rectifying the damage to the house, you start adding thousands onto these costs, right? And we're not considering them. Double glazing, 6,500 on average if you go for PVC. If you go for, timber sash windows, that buys you 2 windows, but that's generally the territory, right? New boiler, it depends who you ask, it's about 2,000 to 3,000, right? And that's cubic, that's less than 3K, right?
That's just the ground floor, though, is it?
We only do ground floors, yes. That's where the cold air comes in and so on. Now, energy savings in pounds per year. And you look at those things, and this is real data, right? This is data from DEC and Mott MacDonald, and guys have gone around, collected data, and did the analysis with us. So, look at the cost, look at the savings. It's a big difference. We save almost as much as solid wall insulation, right? And we sort of third or quarter of the money. When we look at payback time, I love the fact that an item, like new boiler, condensing boiler, probably lifetime of sort of average 12 years, payback of 14. Apart from that, nothing pays back in its lifetime. Yeah, we get there in 14 years, expect lifetime 40. CO2, and that's per pound, because this is where you actually see what you get for your money, right? And people, I started with cost, and I think cost is a big thing for everybody, and it's asking people to spend more money, as much as the intention is to get the right quality. I can't see getting very far, because people look at the budgets and they want to do as much as possible. They want to get the biggest impact for the pounds, and that's that, right? £10. Well, 10 kilograms per pound, and that's higher than anything else in the market. Again, without having to go into the house and cause a trail of destruction, really. So I've put some figures together. You can see the savings payback in lifetime and sort of how long the installation takes. But at the end of the day, that's pretty much what I've covered, right? It is the least intrusive, most effective, and one of the cheapest, apart from loft installation. If you still can do it. Yeah? Apart from that, that is the measure. So, leave you with the, I think it's Mark 5 point something, little device. And the guys are going around and insulating homes. Peabody is one of our early clients, and we've done the first trial for Peabody in March. They've been monitoring the property, and they're quite pleased. They now want us to do more. Same for Camden. We did trials early last year. The data is really good. Camden also looks at the tenants and the feedback from the tenants and so on. It looks very good to them. On top of that, both housing associations and, well, Peabody Housing Association did their own data, and they've worked out that actually insulating the floor using Qbot costs them less than boilers and windows. Even though the savings from boilers and windows are not there compared to what you get. So it's actually a cheaper measure than what they've been doing previously as the cheapest measure. Right? Camden did, Russell did Camden's calculations, or parity projects, and again, Camden did the program of window and boiler replacement. It comes out cheaper when you look at the actual savings that you're going to get out of it. So it is beyond human capabilities, right? That's the answer, right? Can't be done, right? This is all nonsense. It's impossible. You can't get retrofit at scale for less money, and I'm just talking absolute bollocks, right? Or alternatively, there is a way forward. Applying technology that's kind of readily available. I mean, this is all this hardware is stuff that we can put together and buy. The controls are there, right? This is not a Mars lander. It's not far from it. Yeah, it's there. It can be done. So thank you very much on that note. I'll ask for questions.
Looking at the size of it there on that paving slab, what's it about 40, 60 centimetres across?
No. This is
Are they small paving slabs?
yeah. So that's a brick width. So this is effectively 200 mil across here. Everything else pops out. So the idea is that with this generation, we take them apart. So you've got two bolts that pop out. You've got nice good contacts there that actually transfer all the information. That drops through a double vent. Yeah. So we can take this apart, drop it through, put it back together. As long as there's a meter drop. If there's a meter drop, you've got a problem. But that's where survey comes in. And then off it goes. Right. So it's a disassemblable device. We've also got pivoting vehicles that we're building, which you don't have to assemble back together. So they end up sort of, all that sort of twists and aligns, and you get through double vent. So at the moment, double vent is what we do. And if there isn't a double vent in the property, we just knock two bricks out and we put double vent once the job's done, right? It will give you better ventilation under the floor void, which is one of the most important things that we try to retain, because otherwise you'll get problems.
And where it goes, where you have cables going through the floor, do they overheat?
Not if they're correctly specified, so you need to inspect that. But this is a survey. I haven't got a survey bot here. Maybe I should have had a survey bot here. Inspection is a key, because you can have pipework that's leaking, right? You can have issues with your mains, water or gas supplies, right? You might have issues with a wet floor, right? So there is a number of no's that we need to sort of satisfy that they're not no's, they don't strike the property down. So we've had properties where we've identified leaks. Yeah, we said it's a leak there. It's like it's here. Here you've got a leak, right? You can actually get to it with a core hole. Yeah. So that was fixed. Then we came back and did the floor, right? And it's the same with cables. If you've got a double 2.5 mil ring, yeah, on 32 amp fuse, it will not overheat. So if you look at NIC guidance, right, you've got specific levels of insulation that are allowed for cables for size of cable rating, right? And it's not actually that impossible. You come in, you put a fluke in the socket. Fluke is a it's a 500 volts charge that you send through, and you get information back, right? Immediately, you just plug it in, and you know immediately if the cable is the right size, right, for the job. And that's a very critical part of the
Well, I'm presuming
inspection.
that the cable is right size because you put it by Sparks 40 years ago, and all around the wall you've got sockets.
Yes.
So you've got cables looping under the floor. So all those cables should be the right size, not put.
Yeah, if they're the right size, so if you've got a ring of 2.5 at 32 amp, it will not overheat, because it will. The idea is that if you overload that, the fuse goes first. If you put a nail in it, right, your house goes down in flames.
I'm not about putting your insulation in the cover.
Yeah. No, it needs to be it's NIC compliant. That's how we look at it.
You do insulate over them basically.
Yeah, we spray them.
Properly insulate over
Yeah,
them.
if they're right next to the floor, we spray them.
Have you had any issues? I mean, when I've lifted floors in houses, the number of times you get builders rubble under that and going down to
Oh, you loads, yeah.
How much of that can you deal with? As in,
Within half a metre we can spray over it. So because it's all about the angle and so on, right? You just need a clear shot, right? So if you can sort of angle yourself between the joists, right? You can get over that. If it's like 2 square metre area, 4 square metre area, we can't get to it, and we just straight the job down. So I can't do it, sir.
and once you've got your insulation layer under the floorboards, under the floor, I'm trying to think of a circumstance where you need to lift it. I mean, maybe getting to radiator pipes or anything like that. You lift the floorboards.
It comes up. Yeah, I've done it.
Yeah.
I've actually done it because we've when we do a test cell, which is like a 4 square metre sort of room that we've built, and we spray it, and then we take it all out, and we spray it again, we take it all out. So when you take individual boards, they come off relatively easily. The nails are the ones that actually hold it stronger, right? So they come off with a different sound because it's a sort of unsticking sound, and then you see a uniform insulation underneath. You can punch through it, right? That's not, it's not cement.
Yeah.
It's a reasonably moldable substance. You can get to stuff, right? What's positive is that when you've done the survey, right, it's part of the sort of post-job printout. This is where your stuff is. Yeah, these are electrics. This is your part work. That's where it is. If you ever need to get to it, yeah, you've got a map.
Are you saying that you can't do homes on a hillside because you can't drop down into that cavity?
Well, with this hardware, that's the thing. This is. We keep changing our robots every 3 months at the moment, right? So we've got this continuous development. Because each time we go to site, there's a wish list, right? So we probably do half the jobs we look at, because half of the jobs like maybe next year. It's too difficult, too high, too much rubble, or whatever. With this one, we disassemble and assemble. With the next system that we've got coming out, it's self-pivoting. So you can effectively get through to much deeper properties and so on. If you look at the distance from the floor, we work in a space between 25 centimeters to about 70. Beyond that, when you get higher than that, you lose the stickiness of the foam because the chemical reaction is actually taking place between the gun and the impact point, right? So if you start spraying onto a too distant floorboards, you might have to tweak the pressure. It's a process tweaker that at the moment the mobile kits don't have the capacity for. Because bear in mind, with each of those, there's a van full of spray kits. So we get the compressor, you get the generator, and you get the reactor. So actually, it's probably one of the coolest jobs in the world because you can phone up the office and say, "We had a bad day, we blew up the reactor." And that's wonderful. And we've had that happen. So there's a lot of kit, right? You're talking about 250 kilogram barrels with chemicals and so on. It's a factory on wheels, right? And this is just the end device that we get excited about, but it's the entire factory on wheels that needs to work. And then that will be improved further, so we could tweak the pressure, we could cover the further distances and so on. But at the moment, we go for the floors we can do now, right? Because it's getting the customers happy. That's the important part of any business.
How do you deal with the issue or concern about joist ends rotting?
It is a concern, right? Because obviously they are inside the wall, and those bits of the wall are quite wet. At the moment, the approach that was before I go into that, we've got two people looking at this, right, on de-risking. Lisa is one of the persons that we've engaged to ensure that we don't screw up. Andy Simmons, who fell through his floor 20 years ago, about five months after he's insulated because it's all rotten, is looking at that as well, part of a sort of Welsh project. At the moment, the approach is just to leave them slightly exposed, so we don't completely spray them in and then we don't completely spray the wall in. So effectively, what you see is insulation gradually diminishing to the point where they actually meet the wall. So that's sort of exposed and is ventilated. And that part of the wall, which is below the DPC quite often, right, that's also exposed internally. And then the main objective is to actually leave the ventilation, well, most of the time we unblock the ventilation, yeah, but to have the floor well ventilated. Because if we can keep everything there dry, well, we are unlikely to have the breach and condensation issues. A lot of condensation issues and problems with suspended timber floors was caused by either blocking up the vents or putting so much trouble internally that you actually didn't have ventilation routes anymore. And this is something that we're very serious about maintaining and reintroducing to ensure that we de-risk our jobs.
How often do you find where you've got homes where you've got external walls and actually joist ends go into them? Because quite often certainly in a terrace, they'd be running across.
Before I started this, I thought I knew a thing or two about buildings. And then we've surveyed probably in excess of 200 floors now. And they're all different, right? In some cases, they buried in a wall. In some cases, you've got wall plate that sits on a sort of brick ledge, and then everything bats up into that wall plate. In some cases, there's hardly anything there. They're all different, and you have to survey each site, right? Without surveying each site, you just don't know where you are, right? And it's not, when you look at the cost of intervention, right, it actually isn't that prohibitive to send somebody to site, put a survey bot under there through the vent, and collect a whole lot of data that will effectively tell you, yeah, no problem, you can do that job tomorrow, or don't do it for 15 reasons, and this is what they are, right? Half the time it'd be electrics have failed, you need to rewire, you've got a leak, you've got water ingress, yeah, I can see mold on that joist, I don't know where it's from, I don't want to touch it. So you kind of look for reasons why not to do the job. As you can see, we haven't got any salespeople, right, on at the moment on books. You look at it just like, yeah, okay, what can possibly go wrong? And you know, normally, often there's like a washing machine that's pissing, people don't know, right? So you say, there, you've got a leak, just fix it. And because people don't, it goes straight through, right? And it may be deteriorating your fabric for years, you just don't know about it. So you find out a lot, and then you can go for the job or not.
Okay, Tom, I'm going to have to stop you there. So any more
I'll be around for the rest of the day.
Yeah.
So, okay, last question? Last question? We get last question?
No, I'm sorry, no. Because we're going to
Sorry.
move into
I'll hang around.
time and that's not fair. So I could ask you to swap. Thank you very much, Tom.
Thank you.